everyone, welcome to this new section on regression. Regression is a way an average can be calculated between all points provided on a scatter plot. The process of entering all the points on the scatter plot allows one to find the best average of all the given data points. The mathematical process to find the best fit functions for the given data points is tedious and outside the scope of this class. That's probably good news for you. The other good news is that many calculators and Desmos will do the regression calculations for you. The key here is to recognize the shape or trend in the data points and decide on the best regression model from your observations. So with that in mind, let's take a look at this list of data points. I have an input and an output or t-table here, and we need to use this data list to enter data points. So think of these as coordinate points for a scatter plot dot. We can actually get our calculators to do this, or you could also enter it in Desmos, but for now I'm going to show you how to do it on a calculator. So on a calculator, I have a TI-84 plus Silver Edition, and most of the keystrokes will be similar to a TI-83 if you have a very old calculator, or a TI-84 CE, which is the thinner version that is able to be plugged into charge. So depending on what you have, this information will probably work for most of these calculators. So we'll go ahead and turn it on. You want to clear anything that's on the screen, if there is anything, by clicking on clear, and then press stat. Now you need to be able to find stat on your calculator. Stat is in the center column just below the delete button, so it's the third button down. Press 1 for edit, and you can just hit enter here because edit is the default selection. And notice that you're given this L1 and L2 table. If you're given a table of data like you have here just to the left of it, you can enter these points in. If there was a list of data points, click the clear button right here. Do not click the delete button. It's not the end of the world if you click delete, but you'll have to reset your calculator tables, and that does mean it kind of throws off your groove and you have to start over again. So let's go ahead and put 1 and see how it advances. You type the digit and then enter, digit, enter, digit, enter, and it'll fill up list 1. So we will enter all the values in the X column before we enter the values in the Y column. And I'm just going to bring this over a tiny bit more. So 0, 1, 2, 3, 4, 5, 6, and 7. So there are 7 coordinate points, or 7 dots. Now I just arrow to the other list using the left-right buttons, and now I'm going to enter the corresponding digits in the second column, the outputs, or Y values for the coordinate points. 1, 1, 2, 3, 5, 8, 13, and 21. Now, if for any reason the number of entries in list 1 and list 2 do not match, in this case they do, but if they don't, you know you probably either missed a digit or you added an additional digit in that wasn't supposed to be there, and you probably should clear your lists and start over again. Now that we have the data listed, let's go ahead and look at the next instructions. So we entered the data. And now we need to figure out the mathematical model. So the mathematical model will depend on what the scatter plot looks like. And so let's make a graph using the scatter plot. And this is making a scatter graph right here. So we're going to do second quit. And then we're going to press the stat plot. So that means second and then y equals. See that my plot 1 is off? We want to turn that on. So we click enter and see how the cursor is blinking over on, and right now off is selected. We're going to hit enter again. We're also going to check to make sure that our data points are little dots and not an actual graph with connected pieces or a bar graph. We want just dots. And then we're going to check that our lists are correct. We entered data in list 1 and 2, and that corresponds to X and Y, so we're good. And then we can choose a little square for our marks, a plus sign, or a dot. And I don't really care. We'll leave it as little boxes for now, but you can choose whichever one you want. We'll hit enter. Okay, and so now we're going to do second quit. And now push graph. And there are your data points. So when you hit graph, it will show you the data points, but you might be wondering if you have all the data points there. We had 8 entries, and it looks like we have only 6 of our entries showing. So I am going to go to zoom, and then we need to go to zoom all the way down to 9, which is zoom stat, and hit enter. And now it fits the window to the data given. This is really important to make sure that you see the data the way you need to see it and that all the points are listed. So now you need to look at that and decide what regression model you should use. I'm thinking that this would be exponential growth or a quadratic. So now we do a regression model. So to create your mathematical model with regression, you can choose linear, quadratic, logarithmic, exponential, whichever one you think you should use. So we're going to do second quit to exit out of our scatter plot, and then we're going to click on stat, arrow to the right to calc, and we were saying we thought this looked like exponential data. So we are going to click on exp regression, EXP regression. That stands for exponential regression. We're going to hit enter and just double check the data again. List 1 is X, list 1 is X values, list 2 is Y values, and now we need to calculate. So we'll just arrow down until we get to calculate and then hit enter. And it gives us the calculation for that. So now we know what our regression model would be. I'm going to take a snip of this right here so that I have it here in a minute. And so my equation of the line would be, or the curve, y equals, A is 0.7940111355, but let's just go to 4 decimal places just so that we can not have to type in all those values, and it will still be accurate enough. 0.7940, that's our A, times, so now, and I'm just going to put in parentheses B, so B is 1.5872 raised to the X. That's the equation of the line. Now you're probably curious, now does this actually come out as what we're looking for? Let's find out if it does. So we can go into y equals, and this will allow us to actually graph the equation of the exponential on top of the data plot or the scatter plot. So let's type this in. 0.7940, and then open parenthesis, 1.5872, close parenthesis, raised to the x. And the x is right here. And now let's graph that and see what it looks like. That is pretty close. It barely touches the last data point, but it is still a beautiful regression model, and it looks like it's hitting all the dots except for the last one. So I hope this helps you calculate these regression models. Now let's try an actual scenario.